3, 2, 1. Welcome back. Lesson 3. I guess it's 3A. For anybody crazy enough wanting to know where the present value formula for ordinary simple annuities comes from. So I have derived the formula for the future value, and you can definitely watch it. It will help you here. Okay, I've derived it. I'll put a link up above there for anyone who's interested. And that future value formula, so here, okay, if I scroll down, you should be able to see. So if you take all the different payments, okay, so that you have, and so those payments are right here, and then you move all of them to the end, so basically trying to figure out the future value, this is what you would have come up with. And this particular formula right here, so this one, is something that I want you to keep in mind as I'm going to be deriving the present value formula. And in particular, what I want you to keep in mind is actually how this thing right here, okay, so this right there, let me put it in a box, okay, so how it matches, okay, because this simply is that, all right, so that's what that is. Okay, so keep that in mind because I'm going to use that, okay, to actually derive the present value formula, okay? Okay, so let me take this thing again. So I'm going to take this whole thing right here. Okay, so I'll take that. I'm going to copy it. I'm going to bring it down here so that you have it kind of staring you right there. The present value formula is right above there, so you see that on the screen, and we want to see how it comes about, at least for those who are interested. So all my payments that I have, so let me erase this. So all of these payments, what I'm doing is I'm going to be bringing them back here, so to the present value. So this is your present value right here. So if you're going to do that, so your present value equals, okay, so this is your first payment, right? If you're going to bring it back one term, then what you would have is you would have your payment. So this is just using the compound formula. So you would have your payment 1 plus I, where I is the compounding interest. And then this would have been to the minus 1 because you're bringing it one term back. Now, if you do and you bring the second payment back, so what you're going to get payment multiplied by 1 plus I. Now you're bringing it 2 terms back, okay? So that is to the power of 2. And you do this for every single term all the way into the end. So I'm going to say here plus dot, 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 all right, until the end. So the last one right there would have been payment times 1 plus I to the negative n, because we have n payments. So I'm assuming that this is payment number 1, payment number 2, payment number 3, and so on. So dot, 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 all the ways, and this would be payment n minus 1, and then this would be n. So I have all of these. And now, okay, what I'm going to do, and it's kind of a trick when you have this series here in mathematics. Now, of course, you're probably a business student, so you may not care as much. But if you're watching this, I guess you care enough. So how do we do this? What I'm going to do is I'm going to now take this entire thing. So let me kind of take the whole thing right there. I'm going to make it, so let me copy it down maybe, just so that we still have it in both places. So I'm going to paste it. All right, I'm going to make it a little bit smaller so that you can see what I'm going to do. And now let me get rid of this junk there. So that's what I have. And what I'm going to do now is I am going to take and multiply the left-hand side and the right-hand side by exactly the same thing. And that multiplication is going to be actually by 1 plus I to the power of n. And I'm going to multiply the right-hand side also by the same thing, 1 plus I to the power of n. Now, the left-hand side is easy, all right? Because if you do that to the left-hand side here, nothing really happens. So what you have is 1 plus I to the n times your present value equals. But when you multiply the right-hand side, which means you have to distribute it across every single term. So this term right here, let me change color. So this first term right here, if you multiply it by 1 plus I to the power of n, what you're going to get is you're going to get payment 1 plus I. Now it's going to be n minus 1. All right, because the exponents, okay, notice you have -1 and n. Then, secondly, okay, you're going to do that to this second term right here, and what you're going to get is you're going to get payment 1 plus I to the n minus 2. And you would do that to every single term, and then if you do it to the last term, okay, so notice what's going to happen is you're going to, so this last term right here, multiplied by this, so the exponents, negative and n, when you add them together, they equal 0. But you may remember from math that if you have some kind of a number raised to the power of 0, then that is just equal to 1. So we have payment, all right, just remaining because 1 plus I to the 0 is equal to 1. And here is the beauty, because now this entire thing, so if I reverse this, so if I'm going to reverse this, so I'm going to start from payment, all right? So I'm going to go from backwards and then kind of, go all the way to the front. Plus, it's going to be plus payment, 1 plus I, all right? So the next one is going to be 1 plus ... all the way to payment 1 plus I to the n minus 1. So I've just flipped them, all right? So nothing really changes. All I've done is just flip them, okay, in terms of the order. But, okay, so take a look here in that original. So now you have basically exactly this, right? Okay, so if I would copy this down, so if I'm going to copy this down right here, let me copy it. All right, copy. And so I'm going to paste it here. So notice it is identical. Let me do it again here and make it smaller. Okay, it is identical. All right, so they're basically the same. So what that means is that this entire thing, so this right here, is basically just your future value for annuities. And we have derived, so in that original video, well, this is what it meant. So let me copy this down because that's exactly what it is. Okay, it's just basically this. So copy it. Okay, so that entire thing can be simplified to this. So again, so what you have, okay, is you have this. So that's my left-hand side is equal to my right-hand side. Notice, a lot nicer. And now what I'm going to do is I'm going to take both sides. So if I now divide this, so 1 plus I to the n, right? So I'm going to divide both of them by that. So this is going to divide, okay? So that's going to cancel this. And I'm going to bring this, okay, below here. So what I have is that my present value is equal to payment. So that's that. And now so this division right here, it's going to end up in the denominator. So you have 1 plus I to the n minus 1 divided by, all right, and this will be divided by I and 1 plus I to the n. So that's what you have. And now it's just a matter of noticing that you can simplify this, all right? And you understand the exponent rules. So for example, so what I mean by this is if you take this right here, so this is going to be payment, all right, open bracket, okay, and now it's going to be 1 plus I to the n all over I, and 1 plus I to the n minus 1. So I am just distributing the denominator across both. So I'm treating it like a regular fraction there. So that's what that is. And now this falls over, right? So this cancels. Okay, so that is gone. And this right here, this is where you need a little bit of math. Okay, 1, so this right here, so this thing, okay, so let me do that. 1 over 1 plus I to the n is the same thing as 1 plus I, all right, to the negative n. And that is an exponent law, okay? That comes from, okay, this, for those who remember, okay? Those things are equal. And now with that, so what you basically have, let me remove this thing right here. So you have now simplified where your present value, so this is your present value equals to payment. And now that you've simplified this, it's going to be 1 minus, and this is going to be 1 plus I to the negative n all over, and notice all you have left in the denominator is I. And that is your formula for present value. All right, so if you go back, that's exactly, okay, what we had right here. 1 minus, all right, so let's scroll down. 1 minus, there you have it, a little bit of math, okay? If you like the derivation, let me know down in the comments. It is honestly for the crazy people who really want to know. Most people just want to use this formula, and honestly, most people just use their business analyst calculator to compute these things. But, okay, if you wanted to know, there you have it. Okay, thanks for watching. Peace. We'll see you in a future video. Cheers. Bye, everyone.